In this video, we're going to look at piecewise functions. So what is a piecewise function? A piecewise function is a function that is defined by at least two equations. So it can be two or more equations. And these equations apply to different parts of the domain. So these equations will form different parts of the domain. So the equations can be either a constant, maybe it's a constant k, maybe it's a constant k, it's just a constant, or it can be a linear equation where we have x plus a constant c. Then it can be a quadratic equation in this form plus a quadratic equation, of course, general form like this, plus bx. It can be a cubic function, and all those can be a square root and everything. All those equations can be part of this piecewise function. Now let us dive straight into a question. So we have these two questions here. So for each of the following functions, sketch and find. So we're saying we should find f of -1, b, f of 0, f of 3, and its domain and range. And these here, we have one, this is a piecewise function, and the other one is there. So we can see from this question that the piecewise function here in the first one is defined by a linear equation by a constant which is 1, and then by a quadratic function which is just x squared. So this is how a piecewise function looks. So now let us sketch this function. Let us start with number 1. So number 1, the way we sketch an x or y plane like this. So we have our y there and our x there. So how we sketch? So from here, when we look at the first part of it has the first equation, which is x minus 2, x plus 2. So it's y equal to x plus 2. So from here, we have that for everything, for x that is less than -1, x less than -1 should be defined by this linear equation, by this equation. So let me plot the points. So if I have 0, I have -1 there, I have -2. Then on the other side, I have 1 and I have 2, like that. So the way I do this now is, so from here, from my function, from my linear function, I can find where this graph or this equation will intersect with the graph, or with the x-axis. So that is when y is equal to 0. So when y is equal to 0, we have this, we have x plus 2, and this means that our x is equal to -2. So meaning this graph passes at -2. So it goes through -2 like that. Then we have that we have x should be less than or equal to -1, which means at -1 it is closed. So the piecewise function is closed at -1, then it passes through there like that, all the way like that. So it's closed here. Then this is everything less than -1 is going to give us this, and we can see that this continues to go on up to infinity. Then we have that the second part is we have a constant where it's going to be 1 always between -1, x and 1. So these piecewise function can be defined by intervals. So here these are numbers that are in between -1 and 1. So we see that there are no equal, there are no equal signs on the less than symbols, which means that -1 and 1 are not part of this interval. So we can start from where -1 is, then let's say our y is here. So meaning every time anything in between there is going to give us what? 1. So this is going to go through there like that. So now when we see that where -1 is, it is what? Open. So we'll make a bit of an open symbol there like that. So this is how it will be. Then even here we see that it is open like that, so I'll make an open symbol like that. So now the next part is x squared. X squared is equal to so x squared, okay, so x squared, then when x, it's going to be x squared when x is greater than 1. So where there's 1 here, it's going to be included, so meaning there from the function this is included, we're going to shade since it is equal to there. Then now this is on this side is defined by the quadratic function x squared. So when I get values in between here, I square, I will be getting y values going up like that, and this will give me a function that is shaped like this. So this is how I sketch my piecewise function. So now they tell me to find, I have to find f of -1, f of 0, and then f of 3 and the domain. So how do I do that? So from here, to find f of -1, find f of -1, what I do is, so I look at the part which is which defines -1. So -1 is defined by here, -1 going this way, and we see this part here as we sketched is defined by the linear equation x plus 2. So where there is where there's x, we just replace the -1, then plus 2, and this is going to give us 1. So we found that first one. Then for b, we have f of 0. So f of 0 is in between the -1 and 1. And here we have that always when we have those values in between as we've sketched, it's going to give us y equal to 1, which is there. So this is just y equal to 1. Then we have the other one, which is f of 3. So f of 3, so which one defines 3? So anything greater, since 3 is greater than 1 and we had x greater than or equal to 1, it will be defined by x squared. So meaning f of 3 is defined by x squared, then we just put 3 where x is, then this will get 9. So that's how we find that equation. Now the last part says find the range and find the domain and the range. So we see that when we combine all of these, when we combine, okay, so from this, when we combine the domain of this one and that one and this one, then we'll get the domain of the entire piecewise function. So we see that x plus 2 is defined everywhere. So anywhere I can pick any element and that will still be defined. So I can pick any real number and that will be what defined. So same even for the x squared. When I pick any real number, I can square that real number like that, and this is going to give me all real numbers, meaning the domain of the first one is just all real numbers. Then what is the range? So the range for this one, I can put in any value and I'll be getting, so if I put in a number that is so if I put in a positive number, I'll get a positive value. If I put in a negative value, I'll get in a negative value. If I put in an integer, if I put in a rational number, I'll get a rational number. So this will be defined on all real numbers. Then on this other one, on x squared, we see that when we put in values of x here greater than what, when we square them, we'll get positive numbers. But combining the two, including 1, combining the two, we'll just have the set of all real numbers. So that is our range. Now let us answer this second question. So how do we do the second question? So for the second question, we have that our piecewise function, as you can see here, it's 0 between these points, -5 equal to less than x, then we have -x squared plus 4, and then x plus 4 on those points. So how do we do the first one? So let us sketch. So when we sketch, we have that this side we have point -5, and then we have say -2 is here, and then we have 1, and then 0, then we put in 1, and then we have 2, 3, then 4, then we have 5, like that. So from here, what are we going to do? So what we're going to do here, we've been told from, so anything in between -4 Negative 5 and negative 2 should give us what? 0. So let us check in our graph. So let us put that or indicate that in our graph. So where there is negative 5, it's here. And we see it's 0. So meaning it's not moving anywhere in the what? In the y-axis. So it will just be there. Then from there to negative 2. So where negative 2 is, we see that from this, we see that it is open here. So we'll leave it open at first. So this is going to be open. So this will be open here, like that. Then now we have the second one, which shows us, okay, this other part shows us a quadratic function. So this quadratic function has a to be less than 0. So if a is less than 0, it means that our graph is going to open what? Downwards. So then our graph will open downwards. Then from there we can find our x, or we can find our y-intercept. So our y-intercept is found when x is equal to 0. So y is going to be equal to negative x squared plus 4. Then when this is 0, we just have 4 there. So our y-intercept is y is equal to 4. So meaning the graph is cutting the y-axis at 4. So from there it will go, since it's a quadratic function like that, to go, then it cuts there. So this is 4 where it cuts, then all the way like that. But then we see from this part how it's defined. Negative 2 is, there's an equal to sign there, so meaning it's going to be closed at negative 2 and also at positive 1. So if it's closed like that, what are we going to get there? So what we get is this point here is closed, then we have 1 there also being closed. Then we have the next part of this piecewise function to be a linear function, negative x plus 3. Then so it moves from 2 and then 5 like that. So let us graph that. So we have 2, and at 2 we see it is an open interval, so we will leave it open at 2. So it will be open. Then at 5 they are going, it's what? It's closed. So we see that we have this, which is negative x plus 3. So this is what our y is equal to. Then to find our x-intercept, we will say y should be what? Should be 0. Then we have negative x plus 3. Then we have x equal to 3, meaning the graph cuts, or that line cuts the x-axis at 3. So this is going to go cut through 3 there. Then it goes all the way up to 5 and it is closed at 5, like that. So this is how we sketch the graph. Now let us find those points which were being told. So f of negative 1. So f of negative 1, we see that negative 1, we have that negative 1. Okay, so we have that negative 1 is between here, and this here is defined by the quadratic function, which is negative x squared plus 4. So let's just replace there. We have negative squared plus 4, and this is going to give us negative 1 plus 4, which is just equal to 3. So that is our value there. Then the next one is f of 0. So f of 0 also is defined by the same quadratic function, which is x, quadratic equation, which is x squared plus 4. And this is, we replace our 0 where x is, then we just have 0 plus 4, so that gives us 4. Then the other one is f of 3. So f of 3, we see this side, this is defined by the linear equation, negative x plus 3. So where 3 is, we replace, where x is, we replace 3. Then we have negative 3 plus 3, and this will give us 0. Now let us find the domain and the range. So for the domain, we have that the domain is going to be, so it goes here from negative 5. So negative 5 is included. Then we see it goes all the way here up to 1 and it's closed at 1. So comma 1 and it's closed, union, then it goes from here 2, so it's an open interval 2, then all the way up to 5 and it's closed at 5 there. So it is closed at 5 like that. So that's our domain, and our range is going to be equal to, so we see in the y what we get, our highest value there, highest value in the positive x-axis, that is just 4, that is 4. Then we see the lowest that we have, or that we're getting in terms of our in terms of our y, that is going to be negative 2. So that is our range. So this is how we work around piecewise functions.